Here we're given an alkyl bromide and sodium hydroxide, and we want to analyze these conditions and figure out what mechanism this goes through. Is it elimination or substitution? And even further, is it SN1, SN2, E1, or E2? So what we need to do is analyze our entire reaction conditions to predict this. First, we'll look at our bromide. It's a secondary bromide, and secondary bromides can undergo pretty much any mechanism. SN1, SN2, E1, or E2. So that doesn't help us out a lot. But the next thing we'll look at is our base. We have sodium hydroxide, and we can think of this as Na+, OH-. The hydroxide is a strong base and strong nucleophile. So that tells us this can undergo the reaction through SN2 or E2 preferentially. Now a strong base can do SN1 and E1, but it's going to prefer one of these bimolecular mechanisms. So what you want to do is look at what you have and try to come up with a match. And our match here, we have SN2, SN2, E2, E2. This reaction can do both. So let's draw both products. If it does SN2, the hydroxide will just replace the bromine. If it undergoes E2, the base will react with one of the protons at the beta carbon and eliminate to give us the alkene. So these would be the two possible products and the two possible mechanisms. One thing to keep in mind is that typically with secondary substrates is that elimination is favored over substitution. So we will mark this as our major product.